record. Okay, so started the record late, but we are in Tuesday, May 26th with the NetLogo Day 2. We're going to look at NetLogo coding. This is in the book, and so all of, or most of the information that I'm going to walk through today is in the book here, down in these slides in 4.2.1. So I'm actually going to have those slides open, and I'm going to have NetLogo open with the vants. So let me actually show you the vants. So vants are virtual ants, right? So when you open up NetLogo, if you're doing it online, you can just search for ant, and vants will be one of the ones that comes up. That's the one we want. That's the one that I have open here. I have the speed cranked way up. Okay, let me bring it back down to normal. Let me do a setup. A virtual ant, they're just trying to model how insects, and really think, you know, some animals with brains, but really small brains, can do such seemingly complex things with that small brain. And so in their code, where is my Google? Where is my spreadsheet? I don't know why I closed my doc. Here it is. Okay. In the code, it's really just, right, every turn it goes, it's gonna, when it's running, it's gonna tell the ant to move forward and then turn. And that turn is based on the color of the square that it's on. Okay, so it's gonna move forward and then check the color of the square it's on. If that square is white, it's gonna set the color to be black and turn right. Otherwise, it's going to set the color to be white and turn left, right? And so there's two colors, black and white. If it's white, it sets it black, turns right. If it's not white, meaning if it's black, it sets it white and turns left instead. Okay, so that's kind of the Vance algorithm. Let me pull up the Vance picture again. That's not it. I am not good on navigating my screens today. It's this one. Okay. Yeah, I want that big for now. So when I do, I do set up, where's my go button? Okay, that's why I'm not having luck. That is bad. Let me come over here and do it here. This is the NetLogo download. It's really, really similar. Just if you want to find something, you have to go to the file menu and search for the model instead of having a browser on the screen. So let me open up Vance. It should look the same. Zoom, larger, zoom, larger. Okay, we do setup. Oh, I have to do forward. That's why it's not working. Okay, and this little ant is moving around, right? And how it moves is all based on that, right? It moves forward. If the color of the square is white, I'm going to turn it black and then turn right. And if I ended up on a black square, I'm going to color it white and turn left. Okay, and that's what it's doing. If I make this speed, come on, really fast, there. Whoops. Too fast. Set up. So at around 11K, there we go. It starts what they call the highway. And it's just this particular pattern where it keeps moving in one direction with this one set of dots on the screen, right? And that dots just causes it to keep moving in that direction. Okay, see you along. Thanks for letting me know. We're recording this, so you can go check this out later. Yeah, if you need time to go work on your project, go work on your project, get it done, get it turned in. I'm recording this, so I will post it to the HyperDoc probably by noon today. It'll have the links to YouTube and Google Drive, and you can watch it there. So if you do need the time for the AP stuff to turn it in, feel free to drop right now and go do that. Okay, all right, so go ahead, who has a question? I think that was Long saying see ya. So the ant's moving around. It kind of looks like random, but it's not. And then at some point, it bumps into this particular pattern of pixels, black and white, that causes it to do this highway. Okay, now if I set up again, the only thing random in this code is when I do setup, which way it faces, right? So now it's facing down, now it's facing up, now it's facing right. So let's do a right, and I'm gonna let it run for 11K quick. There we go, right? So if it was facing right, what they call the highway goes up and to the left. Do setup again, now it's facing down. We'll get a highway up and to the right, right? If I take a picture of this, if I do setup again, now it's facing left. We haven't seen that one before. So it's not going to be up and to the right or up and to the left because those have been done. There, now it's down and to the right, right? So if I go compare it to this picture, what we see on the screen is the exact same pattern, but just rotated 90 degrees, right? And so it's that the ants are doing the same thing, but which way this pattern develops only depends on that initial rotation, and which way the highway goes only depends on that initial rotation. Okay, so it's a behavior that looks complex, but is actually pretty simple, and they want to walk through the code and make sure you understand that. Okay, so I'm gonna have the project window over here in NetLogo, right? There's three different tabs at the bottom. One is the model info, which has the description of the model and the overview of how it works. There's the code section, right? And there's a command section that's we're not going to use in this class because it's kind of above the scope. Okay, so here's all the code for the VANT, right? There's setup, forward, reverse, and then there's turn. Okay, and here's the book from PLTW. It is a programming language. Lyndon is here. It is a programming language, but it's a little different than other languages. Okay, so the first thing is procedures in NetLogo. It's kind of similar to Python, but like procedures, instead of having a def out front, they have the word to, right? And so the reason it's different is a computer science person created this for biology people who don't really understand programming a lot, to use. So he wanted to make it simpler for them. So he thought it would be simpler that, well, if you want to, to do something, you want to go to that procedure. So to is the keyword that says this is a procedure. This is the setup procedure, which is tied to that setup button. This is the forward procedure, the go forward procedure. So go is normally there's only one button called go. In this one, they have a forward and reverse button. So they have a go forward procedure and a go reverse procedure. And in here, they're calling a procedure called turn, right? Which decides which way to turn based on the color. Okay, so that's kind of the overview. Those are procedures. Every procedure in NetLogo has to end with an end, right? In Python, if you just had something come back and be aligned with the initial def, that meant it was finished. In NetLogo, like a lot of other languages, there's an explicit end to blocks, right? So it ends in the end. Clear all just clears the screen. Now this ask patches, this is a for loop in NetLogo, right? So it's saying, I want to ask every patch of my patches, and patches are, remember in NetLogo, patches are the canvas and turtles are the agents. Okay, so you have canvas or patches, and you have agents or turtles. So it wants to ask every pixel on the canvas, right? So ask patches to just change their color to be white. It's a very polite language until it's telling them, instead of saying set for patch and patches, set color to be white, you ask them, and you don't have to say for patch and patches. You just say ask patches. Ask all of them. It's going to go through them one at a time and do this. And then it has in the book, they say CRT. In NetLogo, they actually came back and said, you know, CRT isn't super readable by a lot of people, so we're going to expand it out into the real name, which is create turtles. Okay, but you could have shortened this down to be CRT. So create turtles number vats. If I switch back to here, there's a slider for the number of vats, right? So I can set this up with 7 vats, and there's a whole bunch of arrows facing in different directions. And if I go forward, you'll see them moving. Yeah, right? So that's the create turtles. I'm going to create 7 turtles or 1 turtle or how many ever turtles they are based on that slider. Okay. And then for each one, I'm going to face them in a direction, right? One of 4 directions. So one of means choose at random, and neighbors 4 is just the list of directions. North, east, southwest, or up, down, left, right. I don't remember if I think it's north, east, southwest. And then we're just going to set the color and set the size, right? So even though we don't know NetLogo, this code is kind of understandable, right? It kind of seems like other programming languages, just a little bit different, right? So the 2 is how they define a function instead of def. They use end to end it. Ask patches, this is a weird way of doing a loop, right? But it's just, okay, I'm going to go through all my patches and do this. I'm going to create turtles, and as I create them, it lets me have a loop to set them up stuff. And then reset ticks just sets tick to be 0. Okay, well, a little odd, but as you kind of look at it, it's like, yeah, okay, I can understand that. Right, face one of neighbors, we talked about. Okay, let's go forward. Okay, so on the screen, right, when I click setup, let me bring this back down to 1, do a setup, now we only see 1 arrow, right? That's this code, right? It cleared everything. It asked every patch to set their color to be white, right? So this is kind of clearing the display, and this is actually initializing the patches to understand what color they were, right? So in here, yeah, I could change this to set their color to be green, and it would set them to be green, okay? And it created how many turtles we wanted to and assigned them a random direction, made them red and made them big so we could see it moving. And it set the tick counter back to 0, right? Tick 0, I let it run, and then stop it, do a setup again, ticks goes back to 0, right? And ticks is a big idea, not a big idea, it's a major, it's part of the running process. We have this idea of ticks. So going forward, when we click the forward button, so it's going to do a for each turtle, and it's going to sort the turtles. Shouldn't have dragged, right? So it wants to go through the turtles. It wants to go through those virtual ants one at a time in the same order every time, right? And that makes it deterministic if on this window here, right? Let's say I had, yeah, that's not, if I start with the same 2 or 3 setup, yeah, if I start with the same 2 or 3 ants, and I could get them to set up the same way every time, then when I run it, they would move the same way every time. It really only works with one. With one, if I set it up facing left and I go forward, right, it makes that shape. If I set it up again facing left and then I go forward, it makes the same shape. Yeah, it will do that with multiple vants, with multiple turtles, if you do it in a for each loop. If I just did ask turtles, it would pick them at random, and then one of them might move forward and set it black, and then the second one might be forward and set it white in this round, but in a different round, if it was doing it at random, a different one might have moved forward, right? And so which way they end up turning could be different. So if you want the agents, the turtles are the agents, to always be deterministic, you need to use a for each sort. Okay, otherwise you could just say ask turtles and it would pick turtles at random and make sure it went through all of them, and you would get a very random behavior, right? And now we're going to ask, right? So for each turtle, right? So for each sort turtles, we're going to get a turtle called T. We're going to ask that turtle to move forward and turn. Okay, in reverse is just the opposite. We tell it to turn, and then we tell it to go back one, and we do a reverse sort, right? So it's really the opposite of a forward. The only challenging code then is the turn, and in NetLogo, if else is basically one question, right? It's the same. Normally we would say in our languages, we would show this as if color is white, no, else, right? It would look like that, right? We'd have a clear if section and then a clear else section. For NetLogo, the developer thought it was clear enough if you just have an if-else statement and then two actions, right? So if it's true, you're going to do the first action. If it's false, you're going to do the second action. Okay, so this is the same if-then-else statement that we're used to. It's just it puts it all into one command line and two actions. One action if true, one action if false. Okay, so that's all the code for the virtual ant. Right up here, I could change it to, I could change its direction if I remembered what the direction names were. I can't do that because I don't remember the direction. Oh, and then there's tick. Sorry, I need to explain tick, right? So tick means set the timer to be timer +1, right? Set another tick on the clock, advance time by 1. In all of the NetLogo simulations, right, this timer up here is running, right? And I was talking about how this highway forms at about 11,000 ticks, right? If I go reverse, I can back it up, right? So, oh.
Wait, at what point does it start like making the little like line that goes out?
It's supposed to be at 11,000, something weird. Let me reverse more. Yeah, the ticks aren't going in reverse. Okay, that's fine. Let me set it up. Sorry, let me turn it off, set it up, and go forward. So forward and reverse is direction. Okay, so here's 11,000, 11,200, and it now has, right, a little bit of the highway, or an inch of the highway going. If I do reverse, it's not reversing ticks, it's just using the opposite algorithm, right? But it can kind of tell us if I slow it down. So we're at 11,200. If I slow it down, that's super slow, a little bit faster. Okay, so it went from 11,200 to 12,300. So it advanced 1,100. So I think the highway actually forms around 10,000. If I set up again and I go forward, a little faster, a little faster. I'm going to try to stop it just after 10,000. Let me slow it down. There, right? And so, yeah, so the highway's starting to form now, right? We can actually see like 3 or 4 stripes of the highway at 10,400. Okay, that's a kind of a fun thing to note, and it's maybe part of the questions they're asking you, but it's, right, they're saying advance that clock 1. And that's kind of how you, if you wanted to use this for biological research and you were talking with somebody else, that's how you talk about it, right? After 10,000 ticks, or at, you know, exactly at tick 10,501, this starts happening, right? So that's kind of the third idea in NetLogo. So you have patches, you have like the canvas, which can operate as a, like the grass, right? It's a non-moving object that things can happen to. You have agents, which can move and things can happen to, and then ticks. You have the sense of time that things may start or stop at certain times if you wanted to. And so you could have code in here where, you know, after, if ticks is greater than 100, then something else is going to start happening. Or every 20 ticks, something happens at random. Okay, so this is kind of the basics of NetLogo code. If, you know, I might want to come in here and create another another agent, right? So I could create, I could create turtles. I'm going to make a green turtle. Okay, and if I come back to, if I come up here, do a setup, and stop playing around with the wrong windows. That didn't work. It's easier to show adding something in the wolf sheep grass one, which I want to show you. Let's go through the code of wolf sheep grass, right? So PLTW is giving us kind of the basics of what the structure looks like. Let's see if we can walk through another piece of code and understand it. Okay, so we have a, let me switch this NetLogo over to wolf sheep grass. Models, wolf sheep. I do recommend, if you have a PC or Mac at home, to actually download the real version of NetLogo, not the web version, because it has a really big library. Let me clear this. Right, so these are all the different areas it has, right? So it has sample models for art, biology, chemistry, computer science, earth science, games, math, networks, philosophy, right? And then it's got curriculum things for that they've added in that different like colleges will use. So say you're interested in art, you might want to come in here and look at fireworks, right? You can look at the description here. You want to open it, you double click, do a setup, do a go. Okay, so for your final project, you guys want to browse around and pick something that interests you. Let me phrase that differently. You want to browse around, and then when you find something, I'm going to tell you a secret. So in the download version, to switch to code, it's a tab along the top. Open up the code and see how much code it is, right? Now I can tell how much code it is. 1 page of code, right, takes up half of this slider, right? So all of the code only takes 2 pages. That's not too bad. If I come back and go to the model library and look at VANT and open up VANTs, double click it, open. Okay, if I switch to code, right? Yeah, it's giving me 2 pages even though there isn't anything on the second page. So the VANT is an easy one to update. If I come to open oops, I come to model and I look up epidem, which is this like a virus distribution model. And I look at that code, right? One page of code is a quarter of the model. So this one's twice as long as fireworks or wolf sheep grass. So this one's much more complex to try to edit. So when you're looking at one to do, right, scroll through the model list, find one where the description seems to be interesting, and then go look at how much code it is. And don't pick one that's 3 or 4 pages of code unless you really feel like spending a lot of time working on your feature, right? You can do something with the Vant or with wolf sheep grass, something that you like. Fireworks isn't too long. I wanted to open up wolf sheep grass. Sheep. Wolf sheep predation, that's the one I'm opening. I'm gonna make it smaller if I can find the edge of my window. Okay, right? And I wanna turn on grass. Setup, okay. So I'm gonna have this on the side as we're going through the code. And I don't need that open. Okay, right, so we have a initial number of sheep, right? We have an initial number of wolves, we have grass regrow time, we have a setup button and a go button. Sheep gain from food, right? How much energy do they get from eating food? Wolves gain from food. How much energy do the wolves get from eating sheep? How often do the sheep reproduce, wolf reproduce? All of this stuff we should expect to find in the code. There's this like a text box here, like a label here that's showing how many sheep we have, how many wolves we have, how much grass we have. Here's the global variables for that, right? Here's how many sheep I have. Here's how many, there should be another globals that shows me the other stuff. In this is how wolves and sheep recreate. There's a built-in command in NetLogo called breed. And it just says this is like the object type, and this is the one we create, right? So I want to create a sheep and its name will be a sheep. I really don't care. I want to create a wolf, right? Of type wolf, and its name is going to be wolf. I don't care what the name is. Turtles have a variable built into them called energy, and patches have a variable built into them called countdown. And so when I do setup, I'm going to clear all the screen. If we're using the NetLogo web version, I'm going to set my max sheep to be 10,000. Otherwise, if I'm using the downloaded version, it could be 30,000. And just the web version runs in Java. Java takes a lot more memory, so they don't want the number of sheep to go crazy. If this model version is set to sheep, wolves, grass, right? And then I'm going to ask the patches to be green or brown, random at startup, right? Otherwise, it's not going to do that. It's going, right? So this is the if else, right? So sorry, I'm trying to grab the proper lines here. So this is the if, this is the else, right? So if I'm in wolf sheep grass, ask the patches to set their color green or brown, otherwise ask their patches to be green. Okay, so I can kind of understand the setup for both of them. Oh, and if we're doing the grass version, I want to set anything that's green to have its countdown equal to this countdown timer. And that's here, right? How often does the grass need to, how long does the grass last if it's not eaten, right? So it'll be born and then it will last for 30 ticks and then die even if the sheep don't eat it. And so we just initialize that here. And then we have a create sheep, right? We're going to set our initial number of sheep. That's here. And right? It's going through and setting things on it. So if we wanted to add something here, say we were going to add bears or eagles or something like that, well, we'd want to create, right? We'd have a procedure to create bears, create eagles. And then we would probably have a slider for initial number of bears, right? And so you could model your update based on one of these other things that are there. And you just have to kind of go through and decide, well, what's it going to be? How is this agent going to behave? Or maybe instead of making an animal, you're going to add a weed, right? And maybe the weeds grow faster, but they give the sheep less energy. Okay, so that's kind of the, So all of this is in that setup function, right? So, right, it asks, are we the web version? If we're the web version, limit the number of sheep. Figure, am I wolf sheep grass or just wolf sheep? If I'm wolf sheep grass, create grass that has a lifetime, and create some dirt patches. Also in setup, I want to create my initial number of sheep. Also in setup, I want to create my initial number of wolves. Okay, I want to display all of the labels we're going to display, and I want to set my tick back down to 0. Right, so if you add something, if you took the wolf sheep model and extended it, right, you're going to need to add something into the setup function to initialize it and, right, make it random. And then you're going to need to add something into the go function to make it react, make it change over time. So in the wolf sheep model, if there's not any turtles, stop. At this point, somebody should ask, oh, Maria asked a question below. Yes, Marita, for your program code, you can take individual pictures and put them together, right? As long as it's one PDF file that they get, they don't care that it was all continuous or whatever initially. It's just for them to see. Sorry, it took me a while to see that.
It's okay. Thank you.
No problem. Hide that stuff again. The problem with trying to use both sides of my screen at the same time is I can't see all that stuff. So here it's asking about turtles. Why is it asking about turtles? I'm dealing with wolves and sheep, right? Turtles is their name for agents, right? Anything that moves is a turtle, right? So wolves are a type of turtle. Sheep are a type of turtle, right? And so this is kind of, we didn't get into object-oriented programming much, but there's kind of a hierarchy of objects. And so I can go through wolves specifically, or I could go through sheep specifically. If I don't care whether it's a wolf or sheep that's an alive agent, I can refer to their master type, their master class, which is turtles, right? Anything that moves in NetLogo is a turtle. Anything that doesn't move is a patch. So I could have a grass patch, I could have a weed patch, I could have a tree patch, and I could have all this code that, right? So here, since it's all just grass, it's not making it a subtype called grass. It's just coloring the patches green or brown. But if I added in something for weed, I would actually have to have a grass type patch and a weed type patch to distinguish between them. Right, so if there's nothing moving around left, stop, because this is supposed to be looking at wolves and sheep. So if there's no wolves or sheep, I want it to stop. If all the wolves have died, I should stop. Or if the number of sheep is higher than the maximum number of sheep it wants to allow, which was that 10,000 for online or 30,000 for download, it's also going to stop, right? The sheep have taken over the world, game over. Otherwise, we're going to ask the sheep to move, and that's a function, right? And if the model is wolf, sheep, grass, then the sheep get energy from eating grass and they lose energy from just being around, right? So here we are, set energy to energy -1, call the eat grass function, call the death function, right? So we have 3 functions we should go check out: move, eat grass, and death. So here's move, right? So it's going to turn right random, 50% of the time, left random 50% of the time, and move forward, right? So this might be true, that might be true, which means it turned right and it turned left again, so it negated it. Or right was true and left wasn't, or left happened and right didn't, and then it moves forward. So sheep are never going to move backwards in one turn. That's move, eat grass. If the patch color is green, well, set it to be brown, and the sheep get energy, set their energy to be their existing energy plus whatever they get from the food. So all of this code is understandable. You just have to kind of walk through it one at a time. So as you're going to extend it, right, you have to say, oh, okay, well, does the thing I'm adding, does it behave more like a sheep or does it behave more like a wolf, right? If it's eating patches, it behaves more like a sheep. If it's eating agents, if it's eating things that move around, it behaves more like a wolf, right? So whatever code you look at and you're going to grab for the final, take a walk through it and just see if you can understand what it's doing. Okay, there's a death function. Let me jump down to that, right? So if energy is less than 0, you die. You don't die from old age, you just die from running out of energy. Here's the wolf procedure, eat sheep, right? If a wolf is on a spot where there is a sheep, right? So let prey be one of sheep here. Where is sheep here? Sorry, that's actually a function. Eat sheep, reproduce, move. Sheep here is not a function. I think this is a built-in one that, yeah, it has to be that they're in the same spot with a sheep. I can't explain that. I'll have to look into that, right? But you get the idea, right? If the wolf is on the spot with a sheep, they can eat it, right? So say let prey be one of sheep here. So this is pick at random. One of the nearby sheep. If it's not nobody, they ask the prey to die, right? Instead of setting the sheep to be dead, and then the wolf gets the energy that it gets from eating the sheep. Wolf gain from food. Okay. I should pause for questions. I've talked a lot. Does anyone have a question?
Yeah, Benoit, are you gonna put like all the instructions in a document, or does that already exist?
That already exists. That is, that is the AP CSP net logo end of semester, right? So that's the fourth link. Here, it says it's the fifth link, but it's the fourth link, right? Click on that. That's the instructions. I can make this bigger and read through them quick, right? So, I got stuff covering up my screen, right? So you're going to go through, browse through the models, pick something that's interesting, right? Or something that you kind of understand. And then you're going to add something to it. Okay, like fireworks. What could you add to fireworks? And so instead of exploding in one color, maybe it's 2 colors. In wolf, sheep, grass predation, add a bear, add a eagle, add a deer, right? Add more things that will eat sheep and that wolves could eat. There's something on traffic, you could add something there, okay? So it should make sense. You shouldn't have wolf-sheep predation where at some random point in time, a nuclear bomb goes off, right? Well, what are we studying with that, right? In traffic, you don't want to have a suddenly a random thing blow up or something, right? Try to add something that makes sense to the model, like you were actually hired, you're a teaching assistant for Mr. Bald, and he's using the wolf sheep predation, and he wants to add in a bear, right? Something that would make logic for that type of simulation, add it in, and then you just have to say, well, what's a simulation? What's a model? Right? And those are slightly different ideas. A model is, right, the computer code that is representing this real life activity in a simplified manner, right? And a simulation is then running that model and seeing how it behaves, right? How does this simulation work, right? So like in wolf, sheep, grass, it's like, well, we have two things. We have patches, right? The things that don't move, that can be grass or dirt, and then we have turtles, which can be sheep or wolves, and they move around, and then the sheep can eat grass and the wolves can eat sheep if they're co-located, right? And then what did you add? And how does that work? Well, I added this eagle, which moves twice as fast, but it also needs more energy. And it can eat sheep and the wolves can eat it, so it needs to be careful. And then what was something cool you learned by doing it, and one challenge, and then just, so make like a 5-slide video, and it should be like 2 to 3 minutes long. Okay, and then here's kind of the rubric, not kind of the rubric, right? So everything works, cool, you get a 3. Right, and I can tell, yeah, you did a good job of your code. The bear behaves like the wolves behave, and they move around and they eat stuff, and their population goes up and down, and right, it looks like somebody from NetLogo did it. Cool, right? Well, I came up with the idea, and I started it, and I started doing my code, and I got bears that move around, but they don't eat anything, and their population never really moves. Right? Okay, so you're not going to get a 3. You could do it, right? An awesome thing, right? Actually, if you get the bear to work, that's pretty awesome, right? You show it and it looks just like somebody at NetLogo did it. That's pretty awesome. You will get a 4. Other questions?
Not for now, at least. I'll just email you just in case.
Yeah. So Thursday, we're going to meet again. It's probably going to be super fast. And it will just be, do you guys have questions? Have you picked out something? What are you thinking of tweaking? Okay, the next few classes, I'm not going to do a lot of talking so that you have this class time to work on your NetLogo code. This should be, 2-3 hours of working in NetLogo. If you added a bear, I could add a bear to NetLogo in 30 minutes. Okay, so I'm going to multiply that by 4 or 5. Right, so that's 2.5 hours. I think most of you guys could add a bear to NetLogo in 2 or 3 hours. But don't all do bears, right? Pick something, go find a model that you think is interesting, fireworks or Vance or something else. And that's it. So I'm done talking for today. If you guys have questions, you are free to come, you're free to ask, but you can also just drop.
All right, thank you, Benoit.
See you, Miguel.
Bye, Benoit.
See you, Maria.
Later, Benoit.
See you, Alex. I'm going to stop sharing Adam and Luis while I take attendance. See you, Luis.
I was going to ask you questions.
You're talking super soft, Adam.
Yeah, my everybody is asleep right now.
Ah.
I just wanted to know because each college board wants the code to be in PDF,
Mm-hmm.
and I do we just like copy the code or like take screenshots of the code inside like a doc where we can convert that to a PDF? Or
So,
how?
in MIT App Inventor, I think if you right click on the screen, it gives you a way of like saving an image, and I think that image is PDF. If that doesn't work, yeah, just take screenshots and paste it into a Google Doc, and then in Google Doc you can export it to be PDF. Make sense?
Yeah.
Cool.
So we can just like all right. So what was the second thing you said?
Sorry, I couldn't hear your question.
What's the second thing you said about the?
So if you can't right click in App Inventor to get it to download a PDF, just take screenshots and put them into Google Doc. And then in Google, you can export PDF.
Yeah, I'll just do it.
Yeah. Okay.
I think that's it. Yeah. Thank you, Mr. Vino.
You are welcome, Adam. Talk to you on Thursday.
All right, see ya.
Bye.